Hello, boys and girls. This is Mr. Bedley. I'll be your host for Excel math lesson number 55 from the 4th grade Excel program. And before we get started learning how to round and estimate, I would like to tell you the beginning, at least, of a joke here. So, where did the computer go to dance? Where did the computer go to dance? You'll have to stay tuned to find the answer to that joke later on in the show. But for right now, we're going to learn about rounding and estimating. First of all, I want to teach you the difference between those two words, rounding. Here's the word rounding and estimating. Some people don't understand why we have these two words and what the difference is. Rounding is what you do to numbers. So you've learned up till now probably 63. If we round that to the nearest 10, we get 60. I did not estimate that number. I rounded that number. Okay, so what is estimating? Estimating is when we round numbers and we get an answer to a math problem that is close. It's the answer to a math problem when we estimate. So we are doing, like, say, 24 plus 18. And instead of doing that problem exactly, and we want just a close answer, and the problem says about how much do you have or something like that, then you are going to estimate. And the way we do this is we round each one of our numbers first. Some people get confused on this and they round the answer. You don't want to round the answer. You round the problem. And so the numbers in the problem. 20 and 20 makes 40, and 40 is our estimate for 24 plus 18. 24 plus 18, the answer is going to be close to 40. Not exactly 40, but close to 40. So that's estimating. Notice the difference between rounding and estimating. The little box here says, when rounding to the nearest 10, you looked at the digit in the ones place. When rounding to the nearest 100, look at and underline the digit in the tens place. If the digit is less than 5, round down, otherwise round up. And the basic idea is that you want to round to the closest number. You're looking for the closest 100. So here we have the number 126. When we're rounding to the closest 100, we're talking about numbers that are even hundreds. 100, 200, 300, 400, and so on. So here's a number line with hundreds written on it. The number 126 would be, each one of these little dashes in here represents 10. So 126 would be about right in here somewhere. It's hard for me with my stylus to give it to you exactly. And you can see that that's closer, much closer to 100 than it is to 200. So that's why we rounded 126 to 100. How about 253? Where would that be? Well, here's 200, here's 300. 253 is between 200 and 300. So we're trying to decide, should I round it up to 300 or down to 200? Well, 253 is going to be just a little bit closer to 300. 10, 20, 30, 40, 50. So 253 is going to be like right in there, which is just barely closer to 300 because it's like 47 away from 300, and it's 53 away from 200, obviously. 253 is 53 away from 200, and so it's a little bit closer to 300, so I say I round that to 300. Go ahead and pause the video, try numbers 3 and 4, then turn it back on for the solutions. So 521, that would be a little bit after the 520, like right in there, and it's obviously closer to 500 than it is to 600. So we round that to 500. 668, it's going to be a little bit past the 660, and it's closer to 700 than it is to 600. So we round that to 700. All right, when rounding to the nearest 1,000, look and underline the digit in the hundreds place. If it is less than 5, round down. So again, here we have some numbers up to 6,000. First number is 5,326. Here's the number 5,000. Here's the number 6,000. 5,326 is going to be like, approximately right in there, which is closer to 5,000 than it is to 6,000, so they rounded it to 5,000. Why don't you give numbers 6 and 7 a shot? See if you can find the closest 1,000 to each one of those. So you should have already done 6 and 7, 2,520. Well, 2,500 is right in the middle of 2,000 and 3,000, right? Somewhere about in there. 2,520 is just slightly to the right of the middle, and so that makes it closer to 3,000. So you should round 2,520 to 3,000. 726 is down in here, a little bit past 700. Not sure if I got that arrow pointing right to the right spot, but I'm sure you get the idea. And 726 is closer to 1,000 than it is to 0,000. And you can put 0 for the closest 1,000. If they gave you the number 180 or something like that, which would be about in here, the closest 1,000 is 0 thousands. But in this case, it's closer to 1,000. So that's what you should have written for your answer. Fix any of these answers that you have wrong as you go through. All right, we are going to be doing these next problems here. We're rounding the nearest 100. Watch out for these because they're actually going to the thousands place. We'll do number 8 together. So we have 1,235. Now we're rounding the nearest 100. The 2 is in the hundreds place. So this number is between, didn't mean to put that there, 1,200 and 1,300, right? Because it's more than 1,200, 1,235. It's less than 1,300, and these are hundreds. Okay, this is like 1,200 and 1,300. Where is that number? 35. Well, 50 would be right in the middle, right? 1,250 is right there, right in between the two. So 35 is going to come down in here, 1,235. Which is closer to 1,200. So the answer is 1,200. All right, pause the video, try 9 and 10, turn the video back on for the solutions. 3,542 is in between 3,500, because we're rounding the closest 100, and 3,600. Which one is it closer to? Well, remember 50 is going to be right in the middle, right? So this is 3,542, which is going to come right in there, and it's closer to 3,500. So that's where we round it to. 5,364 comes between 5,300, there's the hundreds place right there, and 5,400. Right in between is going to be 5,350. This is 5,364. Well, 64 is going to be after 50. 5,364 is going to be a little bit closer to 5,400 than 5,300. So that's what you should have put for that answer. All right, and then here we're going to round each number to the nearest 1,000. So we'll do this first one together. 10,640. Think about the thousands place. That's where the 0 actually is in this. So we have 10,000 as one number, and then the next number up, because we're at 10,640, so that's going to be above 10,000, is going to be 11,000, right? And right in between 10,000 and 11,000 is 10,500 this time, because this is 1,000 from here to here. Well, what's half of 1,000? 500, right? 500 would be right in the middle. 10,500 is right in here. Where would 10,640 be? 640 is more than 10,500. It's going to be in there, so it's actually going to be closer to 11,000 as the number that we would round it to. The closest 1,000 is 11,000. All right, pause the video, try 12 and 13, and then turn it back on when you're ready for the solutions. So the next one is between 12,000, which is an even 1,000, and 13,000, because that's the next 1,000 up. Okay, this is the number 358. Right in between is 12,500. 358 would be down here, a little bit less than 500, so we're going to round that down to the 12,000 instead of going up to 13,000. This number here is between 35,000 and 36,000, right? 35,000, 36,000 would be the next 1,000. 500's right in between. This is 452, which is less than 500, so I'm going to round that down to 35,000. All right, here are some other problems that we have to learn how to do, which is just understanding the language of what they're asking you on these rounding problems here, okay? A primary reason for rounding numbers is so they can be easily be used for estimating or testing the reasonableness of a mathematical computation. In other words, if you do a math problem, an actual math problem, and you get an answer, you can estimate the answer also to see if your answer could be right. Because if your answer is nowhere near the estimate, you're probably wrong. When a rounded number is used for these purposes, the rounded number should have no more than one non-zero digit. So think about what that would mean. Let's take the number 435. All of these numbers are not zeros, they're non-zeros. 4 is not a 0, 3 is not a 0, 5 is not a 0. So if they want you to round the number so that there is only one non-zero digit, only one of these can be a number that's not a 0. The rest of them have to be zeros. So if I rounded this so that there's only one, I'm not going to round it to that place. Well, there's no really rounding to that place. I wouldn't round it to the tens place, because if I rounded the tens place, I would get 440. And that would give me two digits that are not 0. 1 0, 2 not zeros. But if I round it to this place here, I'm going to end up with one digit that's not a 0. Just this one over here. So I'd round that number to 400. And you can see I end up with a 0, and one digit that's not a 0. That's called rounding it to so that there is one non-zero digit. Basically, the trick is you're going to round the numbers all the way to the last place, whatever that one is. So if it's got 3 places like this, you're going to round it to the hundreds place. If there's another number out here, you're going to round it to that spot, the 4th number over, or the thousands place. In this first example, we round it all the way over to this number on the left, which is the 10,000s place. And so I'm finding the nearest 10,000 to 73,000, and that would be 70,000, because this is between 70,000 and 80,000, and it's closer to the 70,000 than it is the 80,000, because 3,574 is less than 5,000, which would be right in the middle. 75,000 would be smack in the middle of 70,000 and 80,000. All right, on this one, we have 96,385. The last digit over on the left is in the 10,000s place again, and this 6,385 tells me that it's above the 5,000, so I've got to round it up to the next 10,000. Well, the next 10,000 after 90,000 is actually 100,000. See, this 9 bumps up to a 10, right? And so we get 100,000. Let's try this next one together here. We're rounding so there's only one non-zero digit, so all of these have to become zeros, and we only want one number left over there. Well, if I round it to 1,000, I'm actually rounding it to the wrong place, because this is 1,534. 534 is closer to the next 1,000 up, which would be 2,000. Notice that my answer has 3 zeros and one digit that's not a 0. So the answer is 2,000. Okay, number 17, I'll just give you a hint. You are rounding that to the thousands place. Why don't you go ahead and pause the video. Turn it on when you're ready for the solution. Okay, so you should have rounded this number, 6,443. 443 is, well, we're between 6,000 and 7,000, right? That's where this number is, someplace in between. And right smack in the middle, 6,500 and 443 is going to be more down in here, closer to 6,000. So the answer is 6,000. Try number 18. Pause the video, turn it back on after you're ready for the solution. 528 is between 500 and 600, but it's closer to 500 because it's not quite to 550. So I put 500 in there. Okay, pause the video, try number 19. And you again are rounding to the last digit over on the left side there, which is the 2. And this 6,385 shows us that I got to bump this up to the next 10,000 or make it 30,000. All right. And then why don't you go ahead and pause the video and do the rest of these, and then turn it on when you're ready for the solutions to those. 9,536 is, we're rounding to this place here, so that 536 tells me go up with it, so the 9,000 goes up to 10,000. 482, rounding to the last spot on the left, 482, but the 82 is closer to 500 than 400, so I go 500 there. And 875, rounding to the last spot, 75 is closer to 900 than 800, so I'm going to round that up to 900. And how about rounding to the closest whole dollar? You should be able to do this, no problem. This is pretty easy. The nearest whole dollar is to the nearest ones place in the dollars. So here I have $2 and here I have $3. I'm going to round these amounts to the closest dollar, either $2 or $3. $2.78 would be, here's $2.70, here's $2.80, $2.78 would be like right in there. And you can see it's a lot closer to get to $3 than it is down here to $2. So I'm going to put $3 in there for the answer. Go ahead and do that on your paper. Go ahead and now do 24 and 25. Pause the video, turn it back on when you're ready for the solutions to those. So $2.50, that's right here in the middle. It's the same distance to $3 as it is to $2. The rule on that is we always go up when it's smack in the middle there. Go up to the next place when you round, and so you're going to round that to $3. $2.36 would be like right down in here, and I don't know if you can see that there. So that's closer to $2 than it is to $3, so round that to $2. Okay, now these are going to be rounded as the closest dollar on this one, and this one. Watch out, we're not rounding as the closest $10, we're rounding the closest dollar, and so in this case we're rounding it to that 9 spot right there. Pause the video and see if you can do number 26. All right, you should have already tried that, and the closest dollar, well, the 54 cents is going to make this dollar, and that's closer to the next dollar up. So the next dollar up after $29 is $30. Here, $14.84, that 84 cents, 50 cents is right in the middle, right? So 84 cents is closer to the next dollar up. Pause the video if you haven't done this one yet. And that would be $15. Okay, and then you should have already done number 28 on your own. 49 cents is just below that halfway point of 50 cents, and so we're actually going to keep that $15. We're going to stay down at the 15 instead of going up to 16. So the answer is $15 on that one. And that's the last problem that you have to do. Whew, that was a long lesson. And let me give you the answer to the riddle. And our riddle was, where did the computer go to dance? You might have forgotten that by now since the lesson was so long. And the answer is to a disco, to a disco, to do some disco dancing. Get it? Because you put a disc in a computer? Well, not so much anymore, but that's the answer to our riddle. Thanks for watching.